Okay, before we discuss the impact of AI on the data center, I guess it'd just be good to understand a little bit of an introduction, well, a little bit about Quetta. Give us a brief introduction to the company, when formed, what it is you do, etc.
Perfect. First of all, thank you very much for inviting me to this interview. It's a pleasure to be here and to have the opportunity to introduce Quetta data center and our view of the data center market. My name is David Hurtado. I'm managing director of Quetta Data Center. I am telecommunication engineer, and I started working as networking engineer at Cisco System many years ago. I earned the CCIE certification, but after a couple of years working as networking engineer, I moved into the finance sector. I spent almost 2 decades working on mergers and acquisitions. I became partner at KPMG, Spain, and also head of corporate finance real estate. And as a partner of KPMG, I advised on the structuring of Quetta. Quetta Data Center was born from the alliance between Azora, which is the largest real estate fund in Spain, and Core Capital, an operating partner with more than 20 years of experience in the data center industry. And when Quetta was launched, I joined them as managing director. So I returned to my legal roots after almost 20 years. In Quetta Data Center is developing a network of data centers around Spain and Portugal. Our data center has a capacity of 10 megawatts each one, and they are near the main cities in Spain and Portugal, Madrid, Barcelona, and Lisbon. The data center are designed to be eco-efficient with no water consumption, and all the power will come from renewable sources. They are also designed for AI. We are adapting the design to the new generations of GPUs that are being launched now, and also the generation that I expect to be launched in the next years, to be able to support them and to offer inference capacity for our customers in the future.
Okay, and you mentioned those 2 magic letters, AI.
Yeah.
I think everyone can agree that the growth of AI is undeniable. But do you have an idea of the estimated impact on the energy demand for data centers in the coming years? I mean, I've seen various estimates, but just give us your thoughts as to how much power is going to be required by the AI explosion.
I mean, the exact figure is difficult to estimate. According to McKinsey's analysis, it's expected that the demand for AI will multiply by 3.5 times between 2025 and 2030, from 44 gigawatts to 156 gigawatts, which is a very significant increase. But in any case, these are estimates. These are not exact figures, because the final figure will depend on different factors. The availability of power, the permitting processes, the supply of GPUs. But in any case, what this estimate from McKinsey shows is that there is a clear trend and a huge demand coming from AI, and AI will be the main driver of demand for data center in the future.
Okay, and in terms of the drivers behind AI, I guess it'd be good to understand what you think of the sort of the real applications, the fields where AI is going to improve our lives. I guess everyone's maybe heard some ideas, but just give us a bit of substance as to where you think AI is going to make a big impact.
Yeah, but this is a very good question, because I mean, all this demand for power comes from real applications. And AI in the future will be everywhere. Will be embedded in all parts of the economy. I mean, for example, in healthcare, you will have AI assisting in surgeries, assisting in medical imaging, developing new treatments. In finance, it will help detecting fraud or advising in investment decisions. In logistics, it will help improving routes or inventory management. And another very exciting area is robotics, the self-driving car, surgery robots. That's going to be a very amazing application of AI. But in any case, which all this application will lead to a relevant part of the characteristic of this AI, which is it will be crucial to have low latency for most of these applications, because imagine in a self-driving car, a delay or a high latency can have fatal impact. So what we have to bear in mind is that AI will come, but the requirements that AI has will significantly reshape the data center industry in the future.
Okay, and we're talking so far about AI as if it's just one single thing. But as I understand it, one of the sort of technical things to understand is there's difference between the current sort of obsession with large language models, the training of AI, and then inference that maybe comes a little bit later. Can you explain how those two phases do differ? And I guess importantly for us with data centers, what's the impact each has in the type of infrastructure that they require?
Yeah, I mean that question is really interesting, because I mean, first of all, before jumping into what infrastructure they need, it's important to identify what training is and what inference is. I mean, it can be very helpful to use the robot example, because robot at the end of the day is AI in the physical world. A robot will need a brain, which is the training phase of the model. At the same time, they will need like a nervous system, which is how this brain interacts with the real world. So starting with the brain, the training phase, following the example of the robot, a robot will need a model for movement, will need a model for perception, and we will need a model for language. So you have to train all this model before putting this robot in the real world. And to train this model, you need an enormous data set, large clusters of GPUs, which means that you need a huge amount of power. I mean, in order to feed this brain with computing power, you need energy. So this will be the training of the brain. And once the brain is trained, you put the brain in the real world, and that will be inference. Inference at the end of the day is AI in action. And this AI needs to receive input from the environment, process that input, and react to this input. For this process to be successful, it's key to have low latency. There is a very interesting study carried out by DKIX, the IXP, where they compare the response time of a robot with the speed of human perception. Because what they say is, if you want a robot to feel natural, the response time of the robot should be in line with the speed of human perception. So a human has a latency, a response time for sounds of less than 1 millisecond. That means that a robot needs to respond in less than 1 millisecond, which means that the computing power of that robot should be within 80 kilometers. Regarding other perception types will be, for example, visual perception. A human needs less than 12 milliseconds to respond to a visual input. That will mean that in the robot world, that will mean that the computing power should be in less than 1,200 kilometers away. And regarding tactile perception, humans have a latency, a response time of less than 20 milliseconds. That will mean that the computing power for a robot should be within 1,800 kilometers. So, I mean, it shows, this example shows how important latency will be in the future. So you have the brain that is trained with a lot of enormous amount of data sets with a lot of power, and when this brain is applied to real world, you need low latency. And this characteristic will define the AI data center industry in the future. Yeah.
Yeah, I mean, picking up on that point, I guess you've explained nicely the distinction between the training and the inference phase. As a result, what type of data centers are already emerging? And I guess from what you've said, we can possibly guess, but perhaps just confirm or expand on the features that set them apart, from the training phase to the inference phase.
Yeah, I mean the training data centers are data centers with a massive scale. To train a model, you need a huge cluster of GPUs, as I mentioned before. So it will be data centers with a lot of power available. Sometimes this data center need hundreds of megawatts or even gigawatts. So, but latency is not an issue for them. So this data center will be away from the cities, close to the power sources. That will be the training data center, and this is the type of data center we are seeing in the news, especially in the US, a huge data center with hundreds of megawatts. And then they will be like the factories of AI. Then you have the second type of data center, which will be inference data center where these brains that are trained are moved into this inference data center in order to interact with the end user. For example, for medical imaging or for self-driving cars, etc., etc. So you need the computing power to be close to the end user, but the most important metric is latency. This data center, this inference data center needs to be very close to the end user, and they need much less power than training data center. So you will have big data center away from the cities with hundreds of megawatts to train the model, and then you will have a small data center, maybe 10 megawatts, 20 megawatts, close near the main cities, to interact with the end user. In Quetta, we are positioning our data center in the second type. We are developing inference data center close to the main cities, with a capacity of 10 megawatts and ready to host these GPUs.
Okay, yeah, and I'm going to ask you a bit more about that, but just before that, I suppose also, is it possible to distinguish between AI data centers, and you've obviously explained there are sort of two different varieties, and traditional data centers? So I suppose what's changing between the data centers that have sort of grown up over the last, I suppose, 5-10 years, and what's now being required? How big a change is it when it comes to AI data centers from, let's say, the traditional ones?
Yeah, I mean that question is also amazing, because I mean you're seeing how the industry is changing in front of your eyes. Because before the racks, and the main driver is power density, because racks, a few years ago, racks had a power density of 2 kilowatts, between 2 kilowatts and 10 kilowatts per rack. But suddenly AI appeared, NVIDIA GPUs increased significantly this power density. The current generation of NVIDIA's GPUs have a power density of 120 kilowatts per rack. So it means that you have multiplied the power density by more than 12 times in just a couple of years. But the roadmap that NVIDIA presented at the beginning of this year showed that by the end of 2027, they will release then the generation called Rubin Ultra, which will have up to 600 kilowatts per rack. So, I mean, in just a few years, you have gone from 2 to 10 kilowatts per rack up to 600 kilowatts per rack. So, I mean, it has a very strong impact in the data center industry, especially because you cannot cool these racks with this high power density with air. You need liquid. When you go when you are hosting racks with 120 kilowatts per rack, you need to deliver liquid in order to cool the equipment. So it means that in the design of the data center, you need to include piping in the data hall. So traditional data center didn't have piping to deliver liquid to the racks in the data hall. You can retrofit the data center, probably, but it's a complex task. It's probably impossible for many data centers, but it can be done. But this is not the only change that you have to do to host AI servers in your data center. When you have a rack of GPUs cooled with liquid, the weight of the rack increased significantly. And traditional data center had a structure with a weight of 500 kilograms per square meter. And with AI racks, you need at least 2,200 kilograms per square meter. So you have to change the structure of your building. And this is a retrofitting that most of the time cannot be delivered. Another important point also is that the value of the racks your AI customer has increased significantly. And so the security protocols, your physical security protocols your customer are asking you are state of the art and are much stronger than before. So can a traditional data center retrofit to be adapted to AI? Some of them maybe can do it. Most of them will not be able. So the AI trend is leading to a new infrastructure of data center able to support higher weights, able to support liquid cooling with state-of-the-art security protocols. So the industry is being reshaped through the AI demand. Yeah.
Okay, I'm going to ask you a bit more about the liquid cooling options in a minute, but before that, just in terms of what Quetta data centers, what you are doing, are you playing in the training phase, the inference phase? What's your sort of strategy, if you like, in terms of responding to this AI demand?
We are focusing on inference and inference phase. I mean, at the end of the day, we are developing data center close to the main cities. So we are offering low latency to our customers. And we are designing the data center ready to host these AI equipments, these AI GPUs. We support a weight higher than 2,200 kilograms per square meter. We support liquid cooling, and we are applying the state-of-the-art security protocol. So our value proposition is to focus on AI inference. Yeah. I mean, it's extremely, and this is a very important point. I mean, as we are close to the main cities, being close to the main cities makes extremely difficult to train models, because in order to train models, you need a high amount of power, and it's difficult to find high amount of power near to main city. You have to go away, far away, to train the models, and the data center that will be close to the cities will be the data center focusing on inference, like Quetta.
Okay, and in terms of the liquid cooling, I mean, as you've explained, there's many more chips in the processors, need more power for AI, more power for the chips, so higher and higher densities coming into the data centers. And as you said, liquid cooling is the solution, but there are different approaches to liquid cooling. So I don't know if you can perhaps just give us an idea of the main ones. I guess immersion and direct-to-chip liquid would be the two perhaps that people have heard of at least, but what are the relative strengths and weaknesses of those?
Okay. No, this is a very, very interesting question also. There are two different technologies in order to cool with liquid. Direct-to-chip and immersion. In direct-to-chip, what you have is a coolant flowing to a cold plate located on top of the hot components, on top of the CPUs and the GPUs. This coolant dissipates the heat generated by the GPUs and the CPUs. That's the first solution. The other solution is immersion. What you do is you take the entire server and you submerge the server in a non-conductive fluid. So all the heat generated by all the components is dissipated by this fluid. Both technologies are extremely efficient. However, the immersion technology is facing a stopper because some of the server manufacturers are not providing warranty if the server is submerged or immersed in the fluid. So many customers are not going for the immersion solution because they don't want to lose the warranty. So right now, the dominant solution, the dominant technology is direct to chip. Maybe in the future, if more manufacturers start providing a warranty for their service, if they're immersed in this fluid, maybe the immersion technology will boost. Because at the end of the day, it's a very good technology. But right now, the dominant technology is direct to chip. Yeah.
Okay, so presumably that's Quetta, you're using direct to chip liquid cooling, and I'm also wondering whether you're using the opportunity, whether now or in the future, people talk about the ability to repurpose the waste heat, capture it and use it somewhere else. So just your thoughts as to liquid cooling as you're using it, and any potential for using waste heat for district heating or whatever else it might be.
No, I mean, in Quetta, we are able to support both immersion cooling and direct to chip, both, because what we do is we have a liquid circuit in the data hall that ends in a coolant distribution unit. The coolant distribution unit, it's an equipment that generates another circuit directly to the rack to cool the rack. So from the we are from the coolant distribution unit and behind, and the customer controls the coolant distribution unit and the rack. So if the customers want to deploy immersion cooling, he has to connect his rack, his immersion cooling rack, with the CDU, with the coolant distribution unit, and he can have immersion cooling. If he wants direct to chip, he can do the same. So our structure is agnostic. We support both technologies. Regarding waste heat reuse, which is a very important point in our ESG strategy, we are talking to local municipalities to find facilities where this heat that we generate can be used. We're thinking about swimming pools or libraries. And also, we are talking to nearby industries that may need heat for their manufacturing processes. So we are analyzing different strategies to deliver the heat that we generate. Yeah.
Okay, and I guess a bit of a sort of future gazing question, which you may or may not have the answer to. It'd just be good to understand what you think. We've talked about AI, both the training, the inferencing, the edge, low latency, importance of there. Do you have any idea or thoughts as to the share of the business over time? Clearly, at the moment, everyone is, large language models training is where all the activity is. But once that has happened, or as that happens, I guess the inference, takes over. But there'll still, so just any thoughts as to, whether you can put it into a ratio or however you want to do it, as to which one may not become important. I know it's a difficult question, but
yeah, I mean, there is a tough estimate. But I agree with your view. I mean, right now we are in a situation where all the investment are mainly dedicated to train the models. This is the reality. But what for the conversation we are having with all the stakeholders and players in the market, especially in the GPU and AI world, expected that in 1-2 years, inference will be reality. We will see more application being deployed, and this application will need power capacity close to the end user. Just the estimate is that right now most of the power is dedicated to training, but in the medium long term, inference will be the main driver of demand. That's for sure. Yeah.
Okay, and in terms of the Quetta roadmap, then it sounds as if you're set up quite nicely to take advantage of that. But at the moment, your focus, as you said, I think is Madrid, Barcelona, and Lisbon. Are you planning to sort of stay within that Iberian peninsula for the time being, or are you already sort of looking further afield, other parts of Europe, whatever? Just anything you can share, I guess, as to how you see yourselves developing over time.
Yeah. I mean, we are focused on the Iberian Peninsula because we believe that the Iberian Peninsula has excellent conditions for data center growth. We are just 50 milliseconds away from 4 continents: North America, South America, Africa, and Middle East. So we are the bridge between Europe and the rest of the world. Thanks to the subsea cables that we receive in Spain and Portugal. Spain also have a very strong fiber network. According to Forbes, this is the second best fiber network just behind South Korea. And we also have a lot of renewable power. During the last decades, there have been massive investments in solar and wind plants. Spain has very competitive energy prices, which makes Spain and Portugal being a very attractive region to invest in data center. And indeed, all the hyperscalers are investing here. For example, Amazon has announced to invest 16 billion euros, 16 billion euros in Spain and Portugal in the coming years. So, I mean, we strongly believe that the Iberian Peninsula will play a relevant role in the growth of data center. And our idea is to take advantage of this momentum before thinking about expanding the business to other European countries.
Yeah, maybe just finally, data center world Spain is coming up, and I guess it's for folks who may be thinking of attending or are, just be good to understand what it is that Quetta is going to be doing there. I guess you've got presence there. I don't know if you're speaking at the conference, but just what can people expect from yourselves at the event?
Yeah, I mean, the data center world is an excellent platform to meet all the participants in the market, to share vision, share ideas. Regarding our participation, I will be giving a presentation on October 29th at 4:30 p.m. and in data center world. And the focus of the presentation will be AI and how AI is reshaping the data center industry. Topic similar to the ones that we are discussing here. So I invite all the attendees to join the session and I will be able to answer as many questions as the audience may have. I'm more than happy to discuss all this topic in person.
Okay, I mean, it's been brilliant to chat, and thank you so much for sharing so many great insights as to what's going on with AI and the data centers, and particularly on the inference side, because as I think we've discussed, the large language models, the training is sort of where everyone's focused. The inference then perhaps gets slightly overlooked. So it's been great to have those insights, and also obviously sharing what's going on at Quetta. So David, really appreciate your time. Thank you.
Thank you. Thank you. And thanks for having me in this interview. It was a pleasure speaking with you and sharing our view of the market. I appreciate the opportunity. Thank you very much.
Thanks again, and hopefully see you in Madrid in a couple of weeks' time.
Hopefully.